Hey there, statistics class. This is section 3.2 in your book, Measures of Variation. And you may notice, hey, Mr. Rising's back in the video. Well, frankly, I got so many just angry comments in the video section that it's, Mr. Rising, you have to come back. So that's what I'm here to do. This is about measures of variation, and I included a picture of Kai and Silas because it's just a cute photo of little boys and flowers in Alaska. But also, it's when we think about how things are the same and how things are different, we can do that quantitatively as well, and that's what statistics is really all about. So when you think about comparing two or more groups or studies or portfolios or classes, there's lots of ways to think about, well, how you could compare. So if you wanted to look at the height of 9th graders and 12th graders, you would expect there to be a difference. Well, you would probably expect a difference in the mode. Maybe they have different maximum heights, minimum heights, ranges. Again, range you're probably familiar with, max minus min, so there's maybe differences in the spread of the data, different averages, medians. Well, we're going to talk about variance and standard deviation here, and how that really plays out in comparing two groups of data. Let me move my picture down here now. So let's imagine I have two data sets. I've got one data set that has 19, 20, and 21. And let's say this is, I don't know, inches of snow in a storm. And these are samples. And I have another data set which has 0, 20, and 40 inches of snow in a storm. Well, let's compare these two data sets. Let's look at the means and let's look at the medians. And as you recall, the mean, if it's a population, right, you add up all the values and divide by the number, or if it's a sample, add up all the numbers and divide by the number of samples you have. And so when you add these up, you get 60, and 60 divided by 3 is 20. All right? You'll notice I also have these in order, and so 20 is the middle number, it's the median. Well, when I do the calculation for data set 2, 0 plus 20 plus 40 is also 60, and when I divide 60 by 3, I also get 20. Okay, and of course 20 is also the middle number. So here are two data sets that have the same mean and median, but clearly they are different. Now, you're probably jumping out of your seat saying, Mr. Rising, come on, just calculate the range, and that will tell us so much more. Okay, well, as a reminder, the range is the difference between the largest and smallest value in a data distribution. So for the range of set 1, I take 21 minus 19 and I get 2. And the range of set 2 is 40 minus 0 and it's 40. So clearly range 2 is much further spread out than range 1. But the real question is, well, how far spread out is it from what you would expect? And this is a big idea in statistics, and this is called deviation, or specifically standard deviation. So deviation is the idea of how far each value differs from the expected value, or the mean. The mean is the expected value. Low, and I'm gonna jump to the board here. Lowercase sigma. Low sigma means data is clustered near central measures. So if you have something, we'll take care of that another time. Let's keep going. Low sigma means data is clustered near central measures. High sigma means data is really spread out. Let's do. Let me show you some math. All right, here we go. So we need a measure of the distribution, right? Of expected value. Again, x bar and mu. Variance and standard deviation provide such measures. So we're going to call these defining formulas, and that's all I'm going to teach you in this class. So sample variance is lowercase s squared. And here's how you do it. And I'm actually going to walk you through it. And if you want to pause the video, you can. Really, all you need to know is how to, well, actually getting both won't hurt. You'll notice these two things are exactly the same, except for the square root sign. And the same thing, if you take the square root of something squared, of s squared, you just get s. Okay, well, what's going on here? So this is how you do it with a sample. You'll notice it's n minus 1. If you want to write this down, that's a good idea. Pause the video and carry on. The next slide looks almost identical, except in this slide, now you're talking about a population, which means you have all the information. You're not missing anything. You have every data set you could possibly think of. So when I look at this one, you'll notice mu is used because that's the population mean. So now instead of subtracting 1, I'm just going to use n. I'm going to the whole number of values I have. And then when I take the square root of the variance, I get the standard deviation. Again, pause the video if you need to. But here we're actually going to go ahead and do an example problem. And I hope that makes everything make more sense. All right, let's see if we can get out of the way. Okay, so steps to calculate standard deviation, and I'm going to show you how this plays out. Start in the innermost section. So this says x, take a sample value, and here we go, calculate the mean. All right, so here are my values, and again, these are the same values I did before. Well, how do I calculate the mean? I add up these values and divide by the number I have. So the sum of x is 0 is 60. Let me scroll down a little bit. And the sum of x divided by n is going to work. Uh-oh. There we go. Equals 60 over 3, and that's 20. So I'm going to call this x bar. Let's say this is a sample. So my mean, I have now calculated my mean. I know my mean is 20, and I'm going to call it a sample mean. All right. So I'm going to subtract the mean from x, and that's what this next column is. Okay? So I've got 19 minus 20. I've got 20 minus 20, and I've got 21 minus 20. Now, you may notice that I didn't actually do the calculation, and the reason why is the next step is to square it. So if you look at this formula right here, it says take the difference, subtract the mean from each x value, and then square it. And then after you do that, you're going to add up all those squared differences. Sum the squared differences. After you do that, you're going to divide by n if it's population, or n minus 1 if it's a sample, and that'll get you the variance. And then we're going to take the square root of it. So again, here's the steps, and I'm going to read them in order. Calculate the mean, subtract the mean from each x value, square each difference, sum the square differences, divide by n or n minus 1, and then take the square root. So here I've got negative 1. Negative 1 squared is 1. Let me just write it out. Here I've got 0. 0 squared is 0. Here I've got positive 1. 1 squared is positive 1. If I add this up, so this is again the sum of x minus x bar, I get 2. Yes! I finally got 2. So now I've just calculated this whole top thing. Sorry about it being a little sloppy there. So let me write this down. I've got 2 sum of x minus x bar squared over n minus 1. I'm going to do this. So I've got 2 over n is 3 minus 1, of course, and that is just a big fat 2 over 2. Well, fabulous. 2 over 2 is really equal to 1. So in this case, I can say, hey, s squared, or the variance is s squared, is equal to 1. Now the last thing I need to do to find the standard deviation, or just s, lowercase s, is just take the square root. So I take the square root of both sides. And the square root of 1, class, of course, is 1. And so the standard deviation for this first data set is just 1. Yay! Who cares? Well, now I can compare it to that other data set, and that's actually the point. So let's go through the other half of this example and calculate it for data set 2. So again, this is data set 1. This is data set 2. Let me extend my page. Here we go. First of all, I'm going to do the sum of x is equal to 60, right? The x bar equals the sum of x over n. So that's 60 over 3, and of course that's 20. So wait a minute. I get it. Well, we already knew that. I already knew I had the same mean. So now I need to do the calculation. 0 minus 20 is negative 20. 20 minus 20 is 0. And 40 minus 20 is positive 20. Well, great. Now when I square these, holy moly, negative 20 squared is 400. 0 squared is 0, and 20 squared, again, is 400. When I add that up, the sum of x minus x bar squared, I get 800. Holy moly. All right, well, now let's continue with the formula. Again, the formula says, hey, I'm not done. I need to take that number and divide it by n minus 1. All right, so let's do that. So now I've got, change colors, s squared equals 800 divided by 2, which is 400. Yikes! Well, now I can take the square root of both sides. So s equals the square root of 400, which is equal to, that one I don't know, I'm going to pull out my trusty calculator for that one. Square root 400, well, I should have known that. 20. Right? So now, what's the point of this? When you compare these two data sets, data set 1 and data set 2, again, just looking at mean didn't work, looking at mode didn't work, even just looking at the range. I mean, I knew data set 2 had a much larger range. But now by using standard deviation, I can quantify the difference from the mean and then compare the two data sets together. Hope this was helpful, and I'll see you in class.